Right, the third problem, let's see. This is a long one. Probably I'll make this a separate video. Find count of good integers. So we are given a n as integer and k, and we are asked to generate uh, all the palindromic numbers, right? So if n is 3, k is 5. So what are the number of palindromic numbers? For example, 515 is a palindromic number which is divisible by k. So this is a k palindromic number, which is what I want. Similarly, 505 is also a k palindromic number. 525 is also a k palindromic number, and this goes on. This is 3. 535 is correct. 45 is correct. 85 and 95. But this is not it. In the answer, we want any arrangement of every k palindromic number in the answer, right? Actually, not in the answer, but the count, right? So this will generate how many arrangements. It is mentioned that we are asked to uh, not have leading zeros, so this is not a possible arrangement, but 550 is a possible arrangement. Let me write it closer. Plus another arrangement is 505. That's it. This is going to create 551, 552, actually 515, 155. Similarly, 3 more from here, 3 more from here, 3 more from here. Here, only 1 because they are repeating. So this is an edge case. Three from here, 3 from here, 3 from here, 3 from here. Alright. Alright. So edge case is this one and this one. Which had at least 1 0. It might be more zeros. Uh, so this is the two edge case that we need to handle, and we are going to do the exact same thing that we did here. So this is what the question is asking. There are two possible scenarios here, three possible scenarios here. So 3, 1, 2. So if you total it, you'll get 27 possibilities. Alright, and that is the answer. So we are going to generate the palindromic numbers, find all of the arrangement for each palindromic number, but for the test edge case, uh, let me write down the steps. First step, generate palindromic numbers. all palindromic numbers which are divisible by k, which is nothing but uh, and of total length n, which is nothing but basically brute forcing. If I do a brute force, is it going to be out of bounds? No. Why no? Because if I take, suppose 0, 0, 0, 0, yeah, suppose n is 5, alright, and k is, uh, I mean, let's forget k for now. If I do a brute force, then I'm basically changing this to 1 and then doing a brute force on this one, changing this to 1, doing a brute force on this one, changing this to 1, and then going back here, changing the this and this to 1, 2, 0, 2, 1, and so on and so forth. So for every half, if I create a vector and for every half of them I will do a brute force and assign it for the right half as I go. So I'm essentially doing a brute force on the generation of palindromic numbers, and I can do the further steps for the condition where it is divisible by k. So this vector is going to be converted to integer, and then this condition is going to be applied, and this is already applied because I will select a vector of length n, and then we are going to do the generation of the various possible rearrangements. For the rearrangement, there is a formula that we can use. Suppose this is the formula, or this is the number that we need to rearrange. Then if I do a rearrangement here, I'm essentially doing what? I'm taking these four values and placing it and finding all the permutations in essentially. Right? So permutation formula, if you remember, the length is n factorial divided by the length or the number of common integers, which is 2 in this case, right? Or let me write in terms of general sense, common integers, the number of common integers, and that's it. But I have not figured out the edge case for this one as well, right? What if there is a 0? So essentially, if there is a 0, then I can find the permutation of, suppose this is the example, the permutation of this particular example. If I fix the first position as 0, then I am essentially removing it from the map that I'm going to have. So this was 1, this is, so it's getting a little complicated, but as we code, I think you will understand. This is a little complicated question, and I was not able to solve it. I saw another person's solution, and that's what I'm trying to explain it here. So let's see. This is what we are fixing. So we are essentially removing it from the map, and what we have left is this. Sorry, this was 1. what we have left is 5, 5, 2. So this is what we are going to call another method where we are going to find the factorial like this formula. So wherever this method is, we are going to call this for this particular map, and we are going to find the this is going to be 3 factorial divided by 2 factorial, essentially this. This is the number of ways where 0 is the leading one. This is the number of ways entirely. So if I subtract, I get the valid number of ways. Right? And by the way, this is brute force, but this is not going to give TLE because I'm going to do half of it and assign it the other half accordingly. So I'm essentially doing a brute force on n by 2, and there are total choice of 10 since 10 digits are there 0, 1, 2, 3, 4, 5, 6 till 9. So 10 to the power n by 2 is the total brute force, and that's 10 is n is 10 in worst case, and this is going to be 10 to the power 5, which is going to be the bottleneck for this problem. 10 to the power n by 2. All right. So let's solve it. Let's code it. I'm going to have a vector initially having 0 values. So this is essentially this. If n is 5, let me remove this. This will be confusing. Right. So vector of num is going to be passed in generating permutations. Right. Num is what I'm passing. So now we did a brute force. We were passing left and right pointer because I'm going to need it, because I'm going to call this recursively and generate all the possible permutations. So left is 0, right is n minus 1, and k is what I'm going to pass. So this is going to create all the permutations, right? But how will I collect it? I will collect it in a map so that I can call the this one as well, right? The rearrangement one. For that I need a map, right? So I'll generate permutations and store it in a map. All right. So let me create a map here. Actually, uh, let's do a void, and I'll create globally the map that I'm talking about. This is the vector. All right. This is the left pointer. This is the right pointer. This is key. And if left is greater than right, that is the point where I have created successfully a palindromic number. It is still not checked that if it is divisible by k or not. That I am going to check it inside. So here I will have a map int comma int. Let me call it map, and in this I am going to actually before that I'm going to have a nums is what is having the palindromic number, but if it is a vector, I need it in form of a digit or I mean integer. Actually, long is what I'm going to prefer because it's going to be large values. Palindrome, alright, palindrome number. Uh, this is going to have function. It's going to be a function vector to num, which I'll call on nums. So let me create that function vector. Actually, this will pass integer. So vector to num vector of num, right? And at this point, I will just create a number which is initially 0 while equal to 0 I less than nums dot size. I'll get the elements one by one and I'll put it in num is equal to num into 10 plus nums of I. Let me, yeah, this is fine. Return num. So right now this is the palindromic num, and I will check if this is divisible by k. Mod k is equal to 0. Right. Let's see. At this point, I will have a map. I'll get the number one by one from palindrome. I mean, get the digit one by one and put it in map. Uh, Digit will be mod 10 plus plus. And at this point, I will divide palindromic number by 10, and this will give me all the digits. At this point, I can generate the number here itself. Alright, or I can do it later on as well, but for that I'll need to store the map somewhere. But there is a edge case that we are missing here, because since we are generating all the palindromic numbers, right, there will be a scenario where, for example, 6 4 7 4 6, right? If this is a number and I'm going to have a map of it, right, and I'm going to use that map to generate all the other numbers. If I do a rearrangement, I will also get 4 6 7 6 4. This is the same frequency of map that this one is, right? But I have already generated all the other permutations which also already included this as well. But eventually afterwards I'm going to generate this again. Actually, I should have mentioned this first and then this, because I'm going to do it in that order. I'm going to have this generated and find all the other possibilities which will include this as well. So I should not have this generated again from the palindromic generation. What I can do? I can do a global set of map which will have, the map, right? So this map of frequency of digits and this map of frequency of digits is going to be same. So it's in set it's going to be only one map, right? So that's what we are going to take advantage of. It's going to be a little bit slower, but it's fine. So let me create a global map, global set of map. Let me call this map. Let me call this MP1, and this should be a map inset because set will need a map inset and not an unordered map. That will give us error actually. So a map is going to be MP1 is going to be inserted inside. So this is a set actually. So let me call this NP set. Finally, I can just move on for the generation or the rearrangement on the permutation. Alright, so permutation. So actually, before that, let me complete the this one. So at this point, I'm having a global set which contains all the map. So for each set or for each map from the set, I'm going to process and rearrange it and get it in my answer. Alright, so answer will have permutations, permutations of this map uh, without the permutations with 0. So for the 0, for the leading zeros, all the permutation that I get, I need to remove it from the total. So yeah, this is it, I think. But actually, let me just instead of doing that, I should actually check if map is having a 0. Uh, in that case, I will reduce one count from 0, or also let me check if map of 0 is greater than 0, in just in case this shouldn't happen, but still let me get the permutations for this map as well. Yeah, this is good, and let me remove this from this here. Yes, okay, this will give me my answer, which I'm going to return here. And finally, permutations, what we need to worry about. There is permutations. Let me create a permutation. Alright. Finally, this will take an or map, and this will take total count is 0 initially. Let me do the permutations like this, the one that I showed. The formula is n factorial by common is a common integers factorial. Right, so for so I'm going to iterate through the math in this permutation function, and I'm going to get the count, the total count, and that total count is going to be for the total, the each individual count for digit is already accumulated inside map. That is the common integers, but the factorial is going to have a so that is going to have a loop on its own, right? So I'll create a factorial group or a function which is going to take probably number, actually n is fine, right? It's not going to be greater, so int is fine. I is equal to 2, I less than equal to n, I plus plus, this is the factorial. Finally, I'm going to finally this one permutation is what I get. So factorial is done. Now I am getting the permutation. So for permutation, as I'm using the formula, this one, n factorial divided by common integers factorial. So common integers factorial is inside map, and n factorial is basically n, that is constant. So I'm essentially calling permutations here. For this, I am passing n as well. Here I will pass n minus 1 instead, because one position is already fixed, that is the first one. So at this point I am getting n. I will have total count as n factorial, and that n factorial is nothing but factorial of n, and I will traverse the map to get the common integers. So essentially num comma common integer count is what I'm getting, and this is going to be divided, total count is going to be divided by every common integer count that I get, but not just that, the factorial of that, factorial of this, and I'm going to return total count. Yeah, so this is what it is, and this is what n factorial divided by common integer count factorial. Finally, this can be completed. This was left behind. So actually, uh, this is the base condition if left is greater than right, so at this point itself I will return. Otherwise, I will call generating permutation again, right? But with what? I will start from here. I will have a digit which will traverse from 0 till 9, isn't it? And this digit is going to, it's going to brute force it basically. So I'm generating, I'll call it again. But before I call it, I will take nums of left and make it digit, and nums of right and make it digit. And I'll call it nums, call the function again with nums left plus 1, right minus 1, and k. That's it. And there, yeah, that's it. But there is its edge case. If left is 0 and digit is 0, right? In that case, it's a leading 0. And in palindromic generation, I should avoid having leading zeros, right? I don't even need it. I can have it. Uh, I actually can't have it, right? There, this will bring me something like 0 0 0 0 0. This I don't even need it because in if I even if I do the subtraction here, it will be invalid because this is what this will give me some value which I don't even need to consider because it's an invalid palindromic, uh, invalid palindromic, whatever k palindromic number, right? So if digit is equal to 0 and left is equal to 0, in that case, please continue. I think this is it. It's a long code, but I think we got this. Let's see if this works. Right, there might be a lot of silly mistakes. It's a long piece of code. Factorial spelling is wrong, is it? Yeah, right. So the spelling is wrong. Let's see if this works. It does. Let's talk about the time complexity. Like I said, this one is going to be 10 choices. For each choice, I'm doing a brute force. For n by 2, it's not very apparent, but it is n by 2 because I am not traversing when left is greater than right. So this is going to be the bottleneck, and so we don't need to worry about the time complexity of these other things. The problem is already too complex. Alright, so yeah, this is it. There might be other scenario, other solutions, but this is what made sense to me. Probably I'll figure out other solutions, and if that does make sense, I'll make a video about it. This is the video. Thanks, guys.